Hello, good morning all of you. नमस्ते बच्चों, हमेशा खुश रहो बिटियाओं. Myself Om Prakash Kesari, Faculty of Education and Methodology, Department of Mathematics. Today I am here to deliver a lecture on analytic function, which is the topic of complex analysis, which are taught in BSc BA PCM 8th semester. Before starting the topic, I will recap a short review on the previous lecture. In my previous lecture, I will taught you the definition of analytic function, what is analytic function, and the condition of function to be analytic, which is the Cauchy-Riemann equation, and Laplace equation, which also satisfied by the analytic function. Now, analytic function is nothing but the function which are continuous and differentiable in a complex plane. Now, in this lecture, the complex analysis has some steps for planning a lesson. These are the preparation, presentation, association, generalization, and their application. First of all, we prepare the lesson and then present that uh, presentation, and then we learn the topics associated with that topic, that lesson, and then generalization of the topic, and find some applications of that topic. These are the some way of learning. The first one is the identification data, aid material. Next one is the instructional objectives, previous knowledge tested, introduction and announcement of topic, presentation, recapitulation, and then finally home assignment. Now, today I'm going to taught you the complex analysis in which are taught in BSc BA PCM 8th semester students, which are comes under science subject of mathematics. Now, today I'm going to simply solve some numerical problem because the theory part of this was over. Now, the first question is to prove that the function mod z square is continuous everywhere but nowhere differentiable except at the origin. That means the function mod z square is nowhere continuous, is continuous everywhere but nowhere differentiable except at the origin. That means the function is differentiable at origin and nowhere but continuous everywhere. For this, we can construct a function which are given. Then we can say let the function f of z equals to mod z square, and obviously mod z square is equal to x square plus y square because x z is a complex function and is equals to x plus iy, and the amplitude of z is equals to under root x square plus y square squaring. After squaring both sides, we get mod z square equals to x square plus y square. Now, it is easier to see that the function x square plus y square is continuous for all x, y. Therefore, f of z is continuous for all z. And we know that the definitions of a derivative is f prime z equals to limit z tends to 0 in any manner. F of z plus del z minus f of z by del z. This definition is comes from ab initio method, or we can say principle of first position. Now, simplifying this function, substituting the value of function, and the value of function is mod z square, then limit delta z tends to 0 in any manner, mod z plus del z का whole square minus mod z का square by del z square. And we know that mod z square is nothing but z z bar. Therefore, we can write mod z plus z delta z whole square is z plus z, delta z into z plus delta z bar. Similarly, we can write mod z square equals to z z bar. Mod z square equal to z z bar. Now, simplifying this function, we know that the sum of mod equals to mod of sum. Therefore, we can write z z bar mod equals to z bar plus delta z bar mod. And we can simplify this by multiplying these. We get z z bar plus z delta z bar plus z bar delta z plus delta z bar. Here, the first and last term are cancel out, and finally we get after division of delta z, limit delta z tends to 0 in any manner, z bar plus z into del z bar by del z plus del z bar. After attacking the limit delta z tends to 0, since the first term is free from delta z, therefore it can be not attacked by the limit, and the last term is delta z, and hence the last term is equals to 0 since delta z tends to 0, therefore delta z bar also tends to 0. And the middle term z into delta z by z bar by delta z, the, since z is free from delta z, therefore it can taken outside, and then limit delta z tends to 0 in any manner delta z bar by del z. After taking this limit, we can take the polar form of the our system. For this, we can take delta z mod equals to r, and argument of delta z equals to theta. Then delta z equals to r e to the power I theta, because delta r e to the power I theta can be written as r cos theta plus ir sin theta. And we already know that the x equals to r cos theta and y equals to r sin theta can be written in polar form from Cartesian form. Now delta z equals to r e to the power I theta, then the delta z bar is must be equals to r e to the power minus I theta. Now using these two equations in the above one, we got f prime z equals to z into limit delta tends to 0 in any manner r by r e to the power I theta minus I theta by r e to the power I theta. Here r cancel out, then plus z bar. Then our functions become f prime z equals to z into limit r tends to 0 in any manner e to the power twice I minus twice I theta plus z bar. Since the function is independent of r, then there is no effect of the limiting value. Therefore, it is equals to z into e to the power minus twice I theta plus z bar, which is not unique because theta is arbitrary. Therefore, we can say that f prime z does not exist. F prime z does not exist because it's not unique. For because theta is arbitrary. Now, let us solve some more problem. Now, we know that the any complex function has real and imaginary part, and the function is said to be analytic if it satisfies the CR equation, and also it has continuous and differentiable function. Then, if any complex function has real part as well as imaginary part, and the function are analytic, then we can find the second one. That means if real part is known, then we can construct the imaginary part as well as the analytic function, and if the imaginary part is known, then we can construct the real part of that function as well as the complex function itself. But if the function is analytic, the condition is if the function is analytic, then we can construct. If the function is analytic and we know the any one part of the complex function, that means real or imaginary, then we can construct imaginary part when real part is known, and when we construct real part when imaginary part is unknown, and also we can construct the analytic function itself. The best example is given here, and in the question form we can say that find the analytic function of which the real part is given as e to the power minus x under bracket x square minus y square cos y plus twice xy sin y. Here the function can be written as f of z equals to u of xy plus iv of xy, which which will be an analytic function. And here u of xy is given as e to the power minus x under bracket x square minus y square cos y plus twice xy sin y. Now we can take the derivative of u with respect to x, and we can write u of x equals to e to the power minus x twice x minus x square plus y square cos y plus twice into 1 plus x into y sin y. And let this function be phi 1 x phi, which is taken as equation 1. Again, we can find uy similarly as we find ux, and take this uy, that means derivative of u with respect to y, and finally we get uy equals to e to the power minus x under bracket twice x minus x square plus y square sin y plus twice x minus 1 into y into cos y, and take this function as phi 2 xy. Now we know by Milli method that phi 1 z0 equals to Milli method that f prime z equals to phi 1 z0 or I phi 2 z0. With the help of this, we want to find the value of phi 1 z0. Since for finding these things, we will take that the z equals to x plus iy, and z bar equals to x minus iy, and we can say that z equals to z bar. The condition is that z equals to z bar. Then we can find z equals to z bar. Then the function is for z equals to z bar, x plus iy equals to x minus iy, x plus iy equals to x minus iy. Then we can see x plus iy equals to x minus iy. X component will be cancelled out. Then twice iy equals to 0. That means y equals to 0. In this case, the imaginary component will be 0. Then our phi 1 z0 is equals to the function at x equals to z and y equals to 0. Substituting the value of x equal to z and y equals to 0 in the above function phi 1 z xy and phi 2 xy. We got phi 1 z0 as e to power minus z twice z into z square plus 0 square into cos theta plus 2 z plus 1 into 0 into sin 0. Then we get e to the power minus z twice z minus z square because sin 0 equal to 0 and cos 0 equals to 1. Now similarly we can find the value of phi 2 z0 as we can as earlier we find phi 1 z0. So phi 2 z0 is equals to 0. Here we can put x equals to z and y equals to 0 as in previous manner, and then find f prime z equals to phi 1 z0 minus I phi 2 z0 with the help of Milli's method. And finally we get f prime z equals to e to the power minus z twice z minus z square because phi 1 z0 equals to e to the power minus z twice z minus z square and phi 2 z0 equals to 0. Now on integrating both sides of this equation, we get f prime z dz integral of f prime z dz equals to integral of e to the power minus z twice z minus z square dz plus c. And finding the solutions of integration, which are very easy, you can integrate these equations. Now f prime z dz equals to f of z, and solving these right hand side part with the help of equation by uh, integration by part, and we get finally f of z equals to z square e to the power y plus c, z square e to the power minus 8 z square e to the power minus z plus c. Therefore f of z equals to x plus iy whole square, since z equals to x plus iy, into e to the power minus z cos y minus I sin y plus c. Now this is the sessions of today's sessions, and finally we can say that this session powered by digital version 2.0 Jayoti Vidyapeeth Women's University. Hope you are satisfied with my digital session. If you have any query, please mention in comment box. I will try to solve it. Thank you.